All right, so this is going to be going over the Kinematics 2 review. Like I said, if you've got any questions, feel free to email me. I will do my best to get through them before I go to bed tonight. I'll do my best to answer. If you got questions, I'll try to be there a little bit early in the morning. All right, so first off, object accelerates concentrated 5 meters per second squared. That means the object, so remember, acceleration means the rate at which the velocity increases. So when you have an acceleration of 5 meters per second squared, that means every second your velocity changes by 5 meters per second. So if you've got a velocity of -20 as your initial velocity, then an acceleration of 5 means 1 second after you begin, it's -20 plus 5 is -15. A second after that, it's at -10. A second after that, it's -5. A second after that, it's 0. A second after that, it's 5. The acceleration is what you add to your velocity every second. So its speed increases its speed by 5 every second. Sure. Decreases its speed by 5 meters per second every second. No, that would be if you had a positive velocity and a negative acceleration. And this doesn't say anything about that. Doesn't move. No. Has a positive velocity? Not necessarily. You can have a positive velocity and a negative acceleration, or a negative velocity and a positive acceleration. Moves 5 meters every second. Absolutely not. So the answer for this one is going to be A. 2. Starting from the origin, a person walks 8 kilometers east during the first day and 5 kilometers west during the next day. What is the total distance traveled from the initial point in 2 days? So this gets into the difference between distance and displacement. Distance is if you had one of those little measuring wheels, that's a meter in circumference that clicks every time it spins once. If I just run down with that, how many times does it click? All the time back and all the way forward. So in this case, you went 8 meters this way, and then you went backwards kilometers this way. So your total distance was 8 plus 5. So 13 kilometers is going to be your answer here. I could ask this exact same question and ask about your displacement, which is the distance between where you started and where you ended, in which case that would be this little chunk here, which would then be 3. But that's not what the question asked. All right, let's see if I can scroll without drawing. And I can. Perfect. Truck travels east with increasing velocity, which of the following is the correct direction of the car's acceleration. So if you are speeding up, your velocity and acceleration need to be in the same direction. So because you are moving right and speeding up, your acceleration should also be to the right. So that's going to be A. 4, a modern car can develop an acceleration 4 times greater. Okay, right, this one. So this one's a little tricky. So look, they say the same distance. They don't say anything about for the same amount of time. So the equation we're talking about here is going to be delta x. Okay, maybe I have to do it here. Delta x equals v naught t plus 1/2 at squared. Now, in both cases, the car's starting at rest, so v naught is going to be equal to 0. But then they say you quadruple the, wait, hold on. What am I doing? This equation has time in it. We want the equation without time. Like in v squared equals v naught squared plus 2a delta x. Now, v naught's still going to be 0. But the thing is, if you have 4 times the acceleration, then this side of the equation is 4 times bigger. So like, again, if I'm going to explain this in terms of like math logic, but if making up numbers works better for you, then by all means, feel free to do that. So the idea is I'm making the right side of the equation 4 times bigger. But to solve for v, I'm going to take the square root of both sides. And the square root of 4 is twice as much. If you get stuck, though, you can just make up numbers. So say a car's got an acceleration of 1 and it's going 100 meters. And another car has an acceleration of 4 times bigger, and it goes the same 100 meters. So what you'd be looking at here is under that equation, v naught 0. So what equation are we looking at? This basically boils down to v equals the square root of 2 times a times delta x. So if we look at one car, it would be the square root of 2 times 1 times 100. So that's square root of 200. So that's 14.14. Again, plus or minus. Don't forget that. In this case, it's not going to matter, but just to keep in mind. And then if we do the same distance, but quadruple our acceleration, there you're going to get the square root of 800, which is going to be 28.28, which, hey, look, it's double. So if the thinking things through mathematically doesn't make sense, try making up some numbers and see what happens. Sorry, I don't have my mouse or keyboard connected to this little tablet, so I gotta very slowly erase everything. It's tedious. All right, number 5, a vector quantity must have a magnitude and a direction. B is going to be your answer here. That's just kind of the definition of velocity of a vector. All right, 6 through 8, we're using this graph here. So 8, what is the distance that the object travels in the first 4 seconds? So the first thing I'm going to see it do anytime I see a graph is look at velocity look at the axes. So this is a velocity versus time graph. So as a reminder, you know, if we draw out the graphs like this, slope takes us down the list, area under the curve goes up the list. Okay, so don't forget that. That's so immediately as soon as I see a graph, I'm going to look at what the axes are. And this is a velocity versus time graph. And I'm immediately going to think slope is going to tell me acceleration. Area under the curve is going to tell me displacement. So 6 says, what is the distance the object travels in the first 4 seconds? This is a velocity versus time. I want displacement, or in this case, distance. I'm only going in one direction. And so I'm just going to do area under the curve. So I'm going to look at this and say, hey, look, at 4 seconds, this is a triangle. With a base of 4, with a height of 8, and a triangle is 1/2 base times height. So 1/2 times 4 times 8 is going to be 16 meters. Likewise, for number 7, what is the acceleration during the first 4 seconds for a velocity versus time? If you're just jumping to this question alone, go back from my spiel before, but the slope of a velocity versus time is going to tell us acceleration. So slope, remember, is rise over run, delta. That's unfortunate. It's delta y over delta x. So delta y over delta x, we go up 8, we go over 4. So that's 8 over 4, which is going to be 2. And that's going to be an answer for that one. Half the video is going to be me erasing things. And then it also asks question 8, what is its acceleration during the last 4 seconds? That would again be look at the slope, and at the last 4 seconds, its slope is horizontal. So it's traveling at a constant velocity, its acceleration would be 0. All right, number 9, as shown in the right, a ball thrown straight up from point A, it reaches a maximum height B, falls back down to C. Which of the following is true about the ball's velocity and acceleration? So without even looking at the options, at the top, your velocity is 0. Throughout your entire path, your acceleration is -10. So its velocity is 0, which is going to be D or E, because A says acceleration 0, and that's just dumb. Velocity is 0 and acceleration is down and non-zero constant, specifically -10 or -9.81. So E is going to be your answer there for number 9. 10, archer practicing with an arrow shoots a bow and arrow, shoots an arrow straight up 2 times. The first time the initial speed is v0, the second time it's 4 v0. How would you compare the maximum height? So again, this is the same as like number, what was it? Number 4. You can think through this logically, and then you can also choose to, make up some numbers if you want. But look, at the maximum height, your final velocity is 0, right? So we still don't have time here. So if we take a look at v squared, which is 0, equals v0 squared plus 2 times a times delta x, or in this case, delta y. We can move the v squared over to the other side. So look, your acceleration is going to be the same. So if I make this side 4 times bigger, and that 4 is squared, then the left side becomes 16 times bigger, right? 4 squared. So the right side must also be 16 times bigger. Can't change the 2. I can't change the acceleration due to gravity. So the height needs to be, it's 16 times bigger. Basically what I'm saying is if I throw a ball up at 10 meters per second, and I throw a ball up at 40 meters per second, the ball that I throw up at 40 meters per second should go 16 times higher than the ball thrown at 10. More erasing. All right. I wish I could find my little drawing tablet. I'm not sure where it went to. All right. So we got some problems here. How many? 6 of them. Okay. Object accelerates from rest. So immediately V naught is equal to 0. To a velocity of 6.2 over a distance of 5 meters. What was its acceleration? So I want acceleration. What I don't have here and what I don't care about here is going to be, let's see, time. So I've done this a couple times already, but v squared equals v naught squared plus 2a delta x. I plug in my numbers. I've got 6.2 squared plus equals 0 plus 2 times a, which is what I want, times delta x, which is 5. So what I'm going to get here is 6.2 squared equals 10a. So 6.2 squared is 38.44. If I divide that by 10, I get an acceleration of 3.84 meters per second squared. All right. A sled with no initial velocity accelerates at a rate of 3.2 meters per second squared down the hill. So a no initial velocity means that's v naught. Accelerates at a rate, that's my acceleration. How long? That's my question mark, which is time. And how long does it take to go 15 meters? That's my delta x. So I've got v naught, I've got a, I've got t, I've got delta x. I do not have my final velocity. So I'm going to go ahead and use delta x, and I'm just going to save myself some time in erasing, equals v naught t, which is all 0, plus 1/2 a t squared. So that's 15 divided by 1.6, because 1.6 is going to be 1/2 times 3.2. So I get 9.38 is equal to t squared. And then I just take the square root. And that's going to give me whatever number it is. It looks like 3.06 seconds is going to be my answer there. Again, I'm assuming on this that, you know, by this point, it's mostly the algebra or the setup. That's the problem. If you're still struggling with the algebra, it might be worth it to pop into math lab this afternoon and, you know, give that a shot, because they can help with the algebra if you can do the setup. 3, an object accelerates from rest. So we once again have a v naught of 0. Constant acceleration of 5.2 meters per second squared. What will its velocity be? So that's our question after 3 seconds, which is time. What we don't have here is delta x. So it's v equals a times t plus v naught. So that's just going to be 3 times 5.2, which is going to be 15.6. All right, object moving with initial velocity, so that's v naught, accelerates at a rate of 1.5 meters per second squared over a distance of delta x. what is its new velocity? So this was another one where we don't have time. So v squared is equal to v naught squared plus 2 times a times delta x. So this is going to be v squared equals 12 squared is 144 plus, let's see, what do we got here? 2 times 40 is 80. Half of that is another 40. So that's going to be 120. So v is going to be equal to the square root of 264, which is a number. 16.25 meters per second. Technically, plus or minus. Be careful of that. All right. And then that really only shows up in free fall. Yeah, can't help you. You got food, you got water, leave me alone. All right, number 5. A ball rolls along the floor with a constant velocity of 12 meters per second. How far will it have gone after 6 seconds? So don't forget, on this equation here, delta x equals v naught t plus 1/2 at squared. If we are traveling at a constant velocity, that means that term goes away. A is 0. Anything times 0 is 0. So this here is our equation for constant velocity. So if you're going 12 meters per second for 6 seconds, then it's just 12 times 6. So that's going to be what? 24 times 3, which is 48, 72. I should be able to do that faster. 72 meters per, or 72 meters. There we go. And then number 6. A stomp rocket takes 3.1 seconds to reach its maximum height. So we don't know v naught. That's what we're looking for in part A. We do know v is going to be 0 because at your maximum height, your velocity's got to be 0. We know a is -10 or -9.81 if you prefer. And we know the time here is 3.1 seconds. So the first thing we can do is v equals at plus v naught and solve for v naught. That's just going to be 0 equals -31 plus v naught. So v naught's got to be 31 meters per second. So now we can find your maximum height, which is v naught times t plus 1/2 a t squared. Now this is where your signs are very important, because if you do your signs right, the math does most of the work for you. So we do 31 times 3.1 is 96.1 minus 0.5 times 10 times. The reason I'm doing the minus is because the 10 is negative, right? So this 1/2 times -10 times 3.1 squared is going to get you -48.05. So you can subtract the number or you can add the negative number. It's the same thing. But by getting these signs right, see, what I'm trying to say is, like, if you made 10 positive, this gives you a completely different number. Because instead of 96.1 minus 48.05, you're getting 96.1 plus 48.05. So then if you actually finish this up, you get, oh, hey, 48.05. Coincidentally, exactly halfway. Cool. All right, last one. And this is an old AP question. As I erase. While I erase, don't forget to smash that like button. I don't care. Some people actually subscribe to my YouTube channel. Why? I'm gonna be the cool kid and subscribe to my physics teacher. All right. 7, first 100 meters, or the first meters of a 100-meter dash are covered by 2 seconds by a sprinter who starts from rest and accelerates at a constant acceleration. The remaining 90 meters are run with the same velocity the sprinter had after 2 seconds. Determine the sprinter's constant acceleration during the first 2 seconds. So what do we have here? Well, we know if you start a race, your initial velocity better be 0, or that's called cheating. We know that time is 2 seconds, and then it's kind of subtle here, but they told you displacement because they tell you the remaining 90 meters of a 100-meter dash. So you accelerated over 10 meters. So let's find the acceleration. And then we're going to find one other thing, even though it does not ask for it. So I really wish this would stop popping up. What do we got here? So we've got, we don't have the final. So it's going to be delta x equals v naught t plus 1/2 a t squared. So that's 10 equals 2a, a equals 5. So there's part A. Now for part B, oh, hey, it does ask us. So never mind. We're going to find part B. To find the final velocity, that's easy enough. It's just v equals a times t plus v naught. So your final velocity is going to be 10 seconds, or sorry, 10 meters per second. Now, the total time needed to run the first full 100 meters, or needed to run the full 100 meters. So we already know 90 meters are run in 2 seconds. The remaining 90 meters are run at a constant velocity. So for that, it's just 90 equals your constant velocity you found in part B times t. It takes you 9 seconds to run the remaining 90 meters, but you ran the first 10 meters in 2 seconds, which gives you a total time of 11 seconds. 9 seconds for the last 90 meters at a constant velocity, plus the 2 seconds it took you to get up to speed. And then on the axes below, draw the displacement versus time curve for the sprinter. So we should start flat because you started at rest. 2 seconds later, we know we're at 10 meters, and you should be curving up because you're accelerating. And then we know at 11 seconds, you're at the 100 meters, and that should be a reasonably straight line because it's a constant velocity. So starting flat, curving to a constant slope, the remaining 90 meters. And that should be it for the review. We got the answers down here, so all that stuff is there if you want a little bit more detail. There were not the answers for this this answer key right here, but that shouldn't be too bad. I also just realized like a chump that all that erasing was pointless because it actually scrolls with and it's not a screenshot. Well, don't I feel like an idiot? So if you got questions and you've stuck with it this long, feel free to email me. I'm happy to respond. Otherwise, good luck. I will see you all tomorrow, and I hope you all have a great day.